Hello, everyone, and welcome. I'm excited to have you here today. We're about to dive into an overview of computer networking. The title of our presentation is Introduction to Computer Networking. Throughout this session, we'll explore the fundamental concepts, how networks work, and why they're so essential in today's connected world. Let's get started. Let's take a quick look at the contents of this presentation. We'll be covering various types of networks, starting with what a computer network actually is. Then, we'll explore the main goals of networks and the different types, including local area networks, metropolitan area networks, and wide area networks. We'll also discuss personal area networks, which are more personal and close range. Moving forward, we'll dive into client-server applications, what they are, how they work, and see an example to better understand their role in network communication. This overview helps us see the bigger picture of how different networks connect and support our daily digital interactions. A computer network is essentially a group of computers that are connected together. The main purpose of this connection is to enable resource sharing. Now, when we think about the most common resource shared today, it's definitely the internet connection itself. But networks aren't just about internet access. They can also include printers or file servers, which allow multiple users to access and share documents or printing resources easily. Interestingly, the internet itself is actually considered a vast computer network, connecting millions of devices around the world. So, understanding what a computer network is helps us see how these resources are shared and accessed seamlessly across different locations. This concept is fundamental as we explore how networks enable communication and data exchange in our digital world. Let's talk about the main goal of networking, which is all about resource sharing. Essentially, the idea is to make all programs, data, and equipment accessible to anyone on the network, regardless of where they are physically located. This means that whether you're in one office or working remotely, you can access the same resources seamlessly. The key point here is that the physical location of the resource or the user doesn't matter. They should be able to connect and utilize the resources as if they were right there with you. This concept really ties into the overall theme of networking, creating a connected environment where information and tools are readily available, no matter where you are. Let's explore the four main types of computer networks. First up is the LAN, or local area network. This type of network typically connects devices within a small, confined space like an office or a building. It's fast, secure, and perfect for sharing resources like files and printers locally. Next, we have the PAN, or personal area network. This is usually a very short-range network that connects personal devices like smartphones, tablets, or wearable tech. Think of it as your personal digital ecosystem. Moving on to the MAN, or metropolitan area network. This covers a larger geographic area, such as a city or a campus. It's often used by organizations that need to connect multiple LANs across a wider area, providing faster communication across the city. Finally, there's the WAN, or wide area network. This is the largest type, connecting devices across countries or even continents. The internet is the biggest example of a WAN, enabling global connectivity. Understanding these different types helps us see how networks are tailored to specific needs, whether it's a small local setup or a vast global system. Each plays a vital role in how we communicate and share information in today's connected world. Let's talk about local area networks, or LANs for short. A LAN is a type of computer network that covers a relatively small geographic area. Usually, you'll find LANs confined to a single room, a building, or sometimes a group of buildings that are close together. This makes them ideal for connecting devices within a localized environment, like an office or school. What's interesting is that even though LANs are typically limited in size, they can still be connected to other LANs over longer distances. They do this using telephone lines or radio waves, which allows for broader communication without sacrificing the speed and efficiency of a local connection. So the key point here is that LANs are designed for small, local areas, but can be linked together to form larger networks. This flexibility is a crucial part of how networks support both small-scale and large-scale communication, fitting into the bigger picture of network infrastructure we're exploring today. Let's talk about personal area networks, or PANs. A PAN is essentially a small-scale network that connects devices around a person. Think of it as a personal bubble for your devices to communicate seamlessly. These networks are typically used for devices that are close to you, enabling quick and easy data transfer. When we look at wireless PANs, or WPANs, they include devices like cell phone headsets, which let you talk or listen hands-free. Wireless keyboards and mice also connect via WPANs, making your workspace cleaner and more flexible. Printers, barcode scanners, and even game consoles are part of this group, allowing for effortless communication without cluttering your workspace with cables. The key idea here is that PANs facilitate nearby device communication, making our daily tech interactions more convenient and efficient. This fits into the bigger picture of how networks are evolving to support our increasingly connected lifestyles, even on a very personal level. Let's talk about the Metropolitan Area Network, or MAN for short. A MAN is a type of network that covers a large geographical area, typically between 5 to 50 kilometers. Think of it as something bigger than a local area network, but smaller than a wide area network. It's often used to connect multiple local networks within a city or a large campus. An important point to remember is that a MAN can serve as a bridge between local networks and wider networks like the Internet. Speaking of which, a WAN, or wide area network, connects LANs and MANs together. The Internet itself is a perfect example of a WAN, connecting countless local and metropolitan networks around the world. So, in the context of our overall discussion, the MAN plays a crucial role in efficiently linking local networks within a city, helping organizations communicate seamlessly over larger distances without relying solely on the Internet. It's a key piece in the puzzle of modern networking infrastructure. Now, let's talk about wide area networks, or WANs. A WAN is a type of telecommunications network that covers a large geographical area, which makes it different from other networks like LANs that are more localized. The main purpose of a WAN is to enable computer networking across vast distances, connecting multiple locations that could be miles or even thousands of miles apart. Most often, WANs are set up using leased telecommunication circuits. These leased lines are dedicated connections provided by telecom providers, ensuring reliable and secure communication over long distances. Understanding WANs is crucial because they form the backbone of global communication, allowing businesses and organizations to operate seamlessly across different regions. In the context of our overall discussion on networks, WANs demonstrate how technology bridges vast spaces, making the world more interconnected than ever before. Let's talk about how a server communicates with a client. Essentially, the client starts the conversation by sending a request, and then the server responds with the information or service that was asked for. This back-and-forth exchange is a perfect example of inter-process communication, where two separate programs or processes are talking to each other. For this communication to work smoothly, both the client and server need to speak the same language. Think of it like a shared code or protocol that both sides understand. They also have to follow specific rules, a set of agreed-upon guidelines, so that each side knows what to expect from the other. This coordination is crucial because it ensures that messages are understood correctly and that the data exchange happens efficiently. Overall, this process is fundamental to how web services, apps, and many networked systems operate seamlessly behind the scenes. So let's talk about what client-server applications are. Essentially, these are pieces of software that run on a client computer, so your local machine, and they make requests to a remote server somewhere else. Think of it like ordering a pizza. Your computer is the customer, and the server is the pizzeria that prepares and delivers your order. Many of these applications are written in high-level visual programming languages. These languages make it easier to design user interfaces, forms, and handle most of the business logic right on the client side. That means a lot of the interaction and processing happen locally, which can improve responsiveness and user experience. Understanding this setup is important because it ties into the overall theme of distributed computing and how different parts of an application communicate over a network. It's a foundational concept that underpins many modern applications we use every day, from web apps to enterprise systems. So let's talk about what a client-server application actually is. Essentially, in this model, clients and servers communicate over a computer network. Often, they are on separate hardware, meaning they might be different computers or devices. But interestingly, both the client and the server can also reside on the same system, sharing resources locally. This flexibility is part of what makes the client-server model so versatile. Now, to make this clearer, think about some common applications you use daily. For example, your email client connects to a mail server to send and receive messages. When you print a document over a network, your computer acts as a client, and the printer server handles the printing requests. And of course, the World Wide Web itself is a perfect example. Your browser is the client, and the web servers hosting websites are the servers. These examples highlight how the client-server model underpins much of our daily digital interactions. It's fundamental to how we access information, communicate, and perform tasks across networks. Understanding this model helps us grasp the backbone of many modern applications and services we rely on every day.